Good morning. Alrighty, so today we have kind of a big and exciting lesson because we have complex figures that we need to determine missing side lengths for and calculate the perimeter of. So I want you to dial back to our area module and think about those strategies that we talked about and learned on, identifying missing side lengths. And even when we only have like maybe a part of the line above or across to help us to determine it. Okay, so let's kick it off and get started. We have the shapes below are made up of rectangles. So that gives us information that we can assume that what is on one side is equal on the other. Label the unknown side lengths, then write and solve an equation to find the perimeter of each shape. Okay, so today we're really going to go back to that checking off strategy and looking at opposing sides to make sure that we are moving through the problem thoughtfully. So you want to kind of get the lay of the land, right, of your figure. So on this side, I have a 3. And what I have over here means I have over here. So I'm actually going to use some highlighters today since it's been a little while since we've done this. So this side length here is 3, which means that anything on this side going up vertically is also going to relate to this side length. So I can see I have 2 here. And do I have any other lines going up and down? I do. I have this one here. Now there's this dashed line, which is coming down into the figure. We don't want to mess with that because that's in the figure. It's helping to draw our eye up to this line, but we are not going to do anything specific with this line other than use it as like a road sign. Hey, look up here. Okay, because this is on the inside. It is the area space, not the perimeter space. So when I'm looking at this, if I have 3 over here and I have a 2 over here, that means that this section also going up and down has to be what? It has to be 1. That's exactly right. Because I have 2 plus 1 equals 3. It's as if this line got pushed in right underneath it. Do I have any other missing side lengths? Now you really have to be systematic. It is easy to miss a side length. So I'm going to kind of touch them. I have that one. I have that one. I have that one. I do not have that one. Now you can see it's getting crowded in here, and it gets crowded in corner spaces. So I'm probably going to put my measurement right here underneath the line. But this line here is the one I want to find. So I'm going to use brighter color than yellow. Okay, so I want to find this line here, which means that I need to look down, right? The opposing side length is going to give me information. The opposite side length is going to give me information as to what that line might be. So down here, I can see I have 4. So I'm going to continue looking up. You have to be an investigator here. That 4 helps me with this, but I still don't know what it is. I have to look for another line that's also going horizontally, which is right here. So this 2 is my last piece of the puzzle to help me figure out this line. So here I have 2. Here I have something I don't know. And here I have 4. So if the whole thing is 4, if I were to take this line and push it and connect it to this one, it would have to be worth what? I have 2 here, and I know the whole thing has to be 4. So this pushed up line would also have to be worth 2, because 2 plus 2 equals 4. And even though this is like drop down, you have to kind of visualize it going up. Okay, 2 and 2 makes 4, which matches down here. Continuing on with my checking of my side lengths. Got it? Got it. Okay, so I'm good to go now. Remember, we are not calculating area. So we are not going to be multiplying side lengths here. We are just going to check them off, list them out, and add up the whole thing. So I'm going to check them off and build my problem underneath this P because it's going to require a little bit of work and calculation. So I have a 3 plus a 2. And again, if you want to use parentheses as you go, just to cluster 2 side lengths at a time, it is a nice little way to work through the problem. And then I have a 2, and I got a 4. Okay. Now that just kind of helps me organize it, lets me see what I'm working with. 3 plus 2 is 5. Make sure you don't accidentally multiply. I've seen that happen. 3 and 6. All right. And then from here, I can just continue to pull down. 5 plus 3 is 8. Don't forget the 6 out here. Plus, whoops, it's not an 8. It's a 6. 8 plus 6 equals 14. So the perimeter of this figure is 14 centimeters. Okay, not so bad, right? All right, let's continue on to B. So with B, we have a full side length given to us of 5. I have a full side length given to us of 2. So it's kind of nice to spend some time identifying like which ones aren't broken apart, because if they're not interrupted with a cut or something like that, that tells you those are going to be important sides for you to use as a tool to figure out what's missing. Now, down here, I have a 2, I have a 1. Oop, this does not have anything, and this does not have anything. And a 2, and this does not have anything. So we have 3 side lengths we have to find. We're going to start off with the most obvious one. Can you figure out which one it is? Which one, if you're looking at this figure, do you think it's going to be the easiest to determine? Okay, let's start with what is, familiar and easy to find. And then we'll turn into our detective super stealth mode. Okay, so we have 2 feet here. That's the easiest one to determine, because if I'm looking at 2 feet here, and I look at the opposite side, I have a nice, clean, uninterrupted line. There's no cuts, there's no parts. It's just the same old line on the other side. So I know that one can get 2 feet. Okay. Now, the next section is a little bit more complex, but you can reason your way through it and keep it pretty manageable. Let's take a look at this 1 foot. Now, this shape that's been cut out is rectangular in shape. This line has another line that we need that is exactly the same size. Which one is it? Yep, it's the one opposite of it. So this 1 foot actually is exactly the same over here. So this side length is going to be congruent. So we can put a 1 foot there. Look at that. We're already down to only needing 1 more side length, which is this one. Now, this one, we know, actually, let's color code since it looks so cool, right? This one and that one are matching. And then I have to find my bottom line here, because I've got a 2 and I've got a 2 and I got this hole. So I'm going to look up. Right? If this line is running across this way horizontally, then I need to find the other horizontal line, which is going to be above it. So here I have 5 feet. I've got 2 feet here and 2 feet here. And this little line is what I need. Now I want you to imagine taking your finger and pushing it down and filling that space. How much would it be worth? You have 2 and you have another 2, that makes 4. So if I push this down, I need it to match this one. It would be worth 1. Yep. Okay, now you've done all this great detective work. You have to stay systematic so that you don't leave out any of these side lengths. Look at all of them, right? And they're in weird spots. So use the checkoff system that we've been kind of practicing here. We have 2. I'm going to list it. Check the 5. I'm going to list it. And I'm going to cluster it, right? Just to build my math problem. I have a 2. I have a 2. Plus, now I am working all the way around. Don't jump around. If you jump around, you're going to skip one. Okay, so I had started here and I'm building around. I'm just following the perimeter, follow the perimeter. Think of it like the yellow brick road. All right, so then I have a 1 foot plus up. I'm still following the road, right? 1 foot plus still on the path. Don't get off the path. Plus 2 feet. There we go. Okay. So now look at those are all nice, comfortable numbers. Now we're all set up. Everything's dialed in. 2 plus 2 is 4, plus 2 plus 3. Okay, I can continue using parentheses to cluster these, or I can just pull them down. We can do a combination of the strategies we like. And 11 plus 5 is 16 centimeters. So the perimeter of that figure is 16 centimeters. It's kind of fun, right? All right, let's continue on. And let's take a look at this figure. All right, so C is giving us, let's identify what we have in terms of solid side lengths. Here, I have a 6. That's going to be an important one. And then looking around, this figure, it has a solid line here. It's got some other horizontal lines. I've got a part over here. So I have to figure out what I am going to do with this 6. Now, this 6 is running vertically, right? Standing up and down. So what I want to do is any other line that is standing up and down or is vertical, I want to highlight that orange. Okay, so looking across my next kind of set, I see a vertical line here. It's going to relate to that 6 meters because it's also vertical and it's on the opposing side. If I continue across my figure, I can see I have another vertical line right here. So I have all these lines, they are all related to this 6, which is why I highlighted them the same color. So this side length is already identified, and this side length is already identified. This is the one that I need to determine. So I have 6 meters here. I have 2. And if I were to take this and to squish it in as if it were a line, one continuous line, right? It would be a 2, and a something. But I have 6 over here. So think 2 and 2 is 4. What's going to create the 6? Yep, another 2. Okay. Now, if we move on to our horizontal lines, let's see if you can see the yellow. It's kind of nicer to use the highlighters than the crayons. Okay, so I have, yeah, that works. All right, so I've got 2 here. This is horizontal. This is horizontal, okay? So I'm gonna highlight that one yellow also. Now, when I look up, that's where my missing side lengths are, right? Now, what's nice about this particular figure is that on this part, we're not going to have to do a lot of like adding or subtracting to figure out these side lengths because look, I have 2 meters here. If I look up, I have an identical match, right? So I just need to label that 2 meters. These lines are completely congruent. They're not interrupted. Nothing's being cut out of them. They're just 2 short lines. When I look here, this 4, and I look up, same situation, right? So that means that this line is exactly identical to this line. No math needed in terms of subtracting from a whole or adding up to a whole. Other side length. Okay, so now, right, now we just get into follow the perimeter mode, follow the path. So I've got 6 and a 6 plus a 2. I'm going to put my 2 and then I'll cluster that with parentheses. I have follow the path, la, 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 and then we're going to come down, right? So now I've got another 2. I'm going to check that off and I'm going to run across. I've got a 4, check that off. I'm still on the path. still on the border, plus 2 staying around the border, the edge, the path, whatever you want to call it. It is all related. Oops, need to check that off. Now, it's the corners that you got to be careful of, right? We're here. Now I'm coming down. Just don't forget them. They're so important. Okay. And then back around to 2. Think of it like a board game, right? You're moving around the board game, and then, I'm back up to the 6. I've completed the perimeter. I've completed the path. I've completed walking around the edge. Okay, 6 plus 2 is 8, plus, I almost multiplied. I've been putting 8s instead of 6s on this one. Plus 6, plus 6, plus 4. Okay, and if I continue that one, I end up with 8 plus 6 is 14. Plus 10 equals 24. So this perimeter is 24 meters. All right, continuing on. Ooh, look at this figure. Okay, so let's see here. I'm getting the lay of the land, right? Let's just maybe use the method of figuring out what we have to find. We have a 2. This is identified. Oh, okay. So see how that one can be sneaky? I'm going to go ahead and put a little line there, meaning I need to put a side length. Follow the line. Now this 2 looks like it's identifying that line. However, it is not. It is identifying this line. So we have to find this side, given, and that one will be handy because it's nice and big, given, and not this one. Okay. So let's start off. Let's see, what's going to be the better way? I've got this nice 7 here. Let's work with the 7. It's our longest line. So let's see what information it can give us. All right. If I do, actually, let's do yellow since I'll keep it consistent here, vertical and horizontal. Okay. So this horizontal line is 7. So remember, we're going to move up and find more horizontal lines. This 2 is horizontal. This 2 is horizontal. I'm going to go back up because this one's kind of set up almost like a weird staircase. And I have a horizontal line. Oh, that's one I need. Okay. And I'm going to go all the way up to the top and I have another horizontal line. So what we have to imagine is like pushing all these down and creating one solid line here so we can figure out what's missing. So I have 2 plus 2, which gives me 4, right? And I know I'm going to end up with 7. I have 4 so far. 2, 4. I have a piece I don't know, but if I connect this piece, if I push all these down, I have another 2. So I have a 2, a 4, which is that one, and a 6. So what does this one have to be? 2, 4, 6, and it has to equal 7. Yep, it has to be 1. This line is 1 yard. Okay, now if we move to our vertical lines, I have a 2 here. Okay. And as I move across, I want to identify other vertical lines. I have a vertical line here. I have another vertical line here. And I have a vertical line here and here. So the vertical lines are pretty chopped up. But let's see what we can figure out. So let's take this by maybe tiers, right? Lower layers of the figure. If I start here, I need to look across here. And what I notice is I don't know that side length, but these lines are clearly the same or congruent. So I know right away I can put a 2 yards there. Now, as I build up in the figure, I have a blank and I have a 4. Now, if this were pushed in, I could see that it would be a total of 6. But for this particular figure, I don't really need to do that because I have this nice long line that is equal to 4 yards. So this 4 yards when I'm looking across this way, I can see that this side length is 2, and this is the last one I have missing. So if this line from here to here is equal to 4, and I already have 2 of it identified, this piece has to be equal to what? 2, because 2 plus 2 will equal this match, right? So if I pushed this line in to create it, you can see it would be the same length. This would be 2 yards. All right, so now that I have all my side lengths figured, it's time to walk the perimeter path. I have 2 yards plus 2 yards stay on that line. I'm telling you, they get sneaky. Now I'm going up the path. I have another 2 yards. I'm staying on the path and it turns a corner, right? So now I'm on 1 yard. And now I'm going to walk up a super steep cliff, 2, and then I get some flat road here. Some downhill, right? Visualize it however it's going to help you. It's kind of fun to make up a story as you're walking around. Now we get to turn, but it's still flat road. I'm running out of space and my head is covering the math. Okay, so I'm here. There's my 4 plus my 2, which I just did. I'm gonna have to squish. I did not pre-plan this very well. I wrote too big. Okay, so then my last one would be 2 yards plus my 7. Okay. As we add it, it'll shrink up. Okay, so here I have 4 plus 3 plus 4 plus 6 plus 9. Okay, and then I'll pull them down. I get 7 plus 10. Remember, this is a pull down, right? We pull that operation down in the digit. And then I have 17 plus 9 equals 17 and 9 is 26. So this one is 26 yards. Isn't that crazy when you look at perimeter? Like this one is only 2 yards longer, or 2 units of measurement longer than this one. It just seems like this would have a lot more, right? And they're using fairly similar numbers, but perimeter can kind of be deceiving sometimes. All right, continuing on. Nathan draws and labels the square and the rectangle below. Find the perimeter of the new shape. So when they say new shape, okay, they mean this whole thing. Okay, so this is the new shape. Even though it's shaded, you'd have this square, you have this rectangle stuck together. We have to find the perimeter of the whole thing, which means, are we going to do any labeling on this line? No, because why? Right, it's on the inside. And then on the inside is not the perimeter, it is the area. All right, so we just need this figure, just the outside edge, and we need to label some dimensions because as you can see, we have some missing side lengths. Now, let's take a peek here. We were told, this one has some information that you have to pay attention to. We were told that he has a square, which is right there. What do we know about squares? We know they have all equal sides, right? So if this side is 6, what is this side? Yes, this side is also 6. It has to be. And that would be 6, but we're not going to label it because it's the area. And that would be 6, but I'm going to hold off labeling that one, and I'll show you why in a second. So I have this one, this one. Now, this whole line, right, means that it's a section of 12 and a section of 6. Well, what is that whole amount? If I wanted just one solid line running across, what would it be equal to? It would be equal to the 6 plus the 12, which would be 18 centimeters. So now that I know that, can I identify this side length? It's down here. And what's down here is equal to what's up here. And I just found out through reasoning that it's a solid 18. So I'm going to go ahead and put that 18 up here. Now be careful when you're adding these up. You either can add in just this 18 down here, or you could add the 12 and the 6. I'm going to stick with the 18 though, okay? Because it'll keep it a little more simplified. All right, so we have 6. I'm going to start my path over here, plus 18. There's my first set to add up. Moving around, I'm going downhill, and I've got the 6. Plus, now I am making a left, and I am walking that straight line, which is 18 centimeters. Ah, look at that. This is going to be nice, because once I figure out 6 plus 18, I'll be able to just double it. So I have 24 here plus 24 here. There's the doubling, right? And 24 plus 24 is 48 centimeters. That's the perimeter. Okay, last one. Label the unknown side lengths, then find the perimeter of the shaded rectangle. Label the unknown side lengths. Okay, well, let's figure out. Oh, look it, they put variables in there for us. So this is our unknown here, and this is our unknown here. So let's take a look. Should we do the verticals or the horizontals first? Let's do the verticals first. Okay, so that means I'm going to take this 7, and I'm going to look for any other lines that are 7. But be careful. This is sneaky, because if I were highlighting, I have this line right here. Is it in the figure or on the outside of the figure? It's in the figure. I'm going to skip it because it's in my area. Get out of my area, right? We just need the perimeter. So I have 7 here. So I'm not going to mess with something in my area. I only want what's on my perimeter, which is this line here. Okay. Now, looking at those 2 lines, I have a total length of 7. And over here, what's nice is it's straight up and down. So there's no having to like imagine things getting pushed in or out. I have 2 here, which means that has to be what? If I have 2 here and 7 here, this is the same length. So it has to be, what's 7 minus 2? B has to equal 5 inches. Okay, because 5 plus 2 is 7, which is what's over there. Now on my vertical line, okay, I've got this nice big 16 inches, okay? Now, looking up, again, you know the last problem on these problem sets is always the hardest, right? So what they're having you really have to recognize is that this shaded space is not perimeter. This shaded space is area. So you have to shove that out of your calculations. You don't want to get stuck in this trap, right? Because they like to see, are you paying attention? Do you really understand what perimeter is? Yes, we do. Thank you very much. We know it's only the outside edge. So you can go ahead and shade that figure all you want, but I know I just need this line, Mr. Problem Set. Okay, so I've got that line. So I got 16 here, and I'm looking up. I got 8 here, and I got mystery number over here, right? So if I have 16 down here, and I got 8 here, what's this going to be worth? 8. Yep, I know you guys know it. 8 inches. Okay, that A is going to equal 8 inches. Now we're ready to add it all up. So let's walk this nice rectangular path, right? We got 7 inches plus 8 inches plus our discovery of another 8 inches. Going downhill, right? I got 5 inches. Plus I've got my 2 inches. And then I got this nice long clean line. That's just a straight 16. And I'm back up to the beginning. If I add these up, 7 plus 8 is 15. plus 8 plus 5 is 13. Plus 2 plus 16 is another, oh, not another, an 18. Okay, then I got to keep adding 15 and 13. No regrouping here, so I'm not going to stack, but I have 8, I have 28 plus an 18, which is going to have regrouping. I don't mess around with regrouping. I don't recommend you do either. I know we all have these fabulous mental strategies, but when you've done all this work, are you really going to blow it because you forgot to regroup a 10? That is such a bummer. 8 plus 8 is 16. Regroup your 10. Don't forget to add it in. All you guys sometimes put it up there and you forget to put it in there. 2, 3, 4. 46. 46 what? 46 inches. Done. All right, I can't wait to see your work. If you have crayons or highlighters and you really like that identification strategy, knock yourself out. It'd be fun to see how you organized your process and how you went through the work and kept it organized for yourself. All right, don't forget to submit your homework, and I will see you next time. Bye.